Einstein's worldview of science, we celebrate what it generated, but if we insist that what we celebrate is the equation, then this is what we celebrate. Isn't this a reason for a party? Thank you.
So thank you for this fascinating overview of the history. I might just remark, he said that he never mentioned this, what he called blunder. In English translation it's called the biggest blunder of my life.
Yeah.
But in German the word that was used was actually Eselei, which is this, esel means donkey. And I've been asking around where this is documented or is it written, but apparently he just said it to people.
He said it to Gutfreund. He said it to Gutfreund. That's where it is explicitly stated, and historians tried to trace that. It is nowhere.
There's no written.
There is nowhere written evidence. I think that this footnote is the closest to a regret that I could find, and it unfortunate that you regret it.
Well, thank you very much. If there are any comments or brief questions, not bad.
With the Mach principle, I've always the question whether there ever was an idea to distinguish between near infinity and far infinity, because if we calculate rotation by the Lenz-Turing effect, do we take as reference the stars of the Milky Way, which are far away, but which are still near? Or do we take the distant quasars? As far as I know, there is no experimental evidence whether the Turing-Lenz effect, which we calculate, relates as respect to the far distant stars in the Milky Way, or far away. But philosophically, you would first of all have to distinguish between a near infinity and a far infinity. Has this ever been a criticism of the Mach principle, that it does not really say what are the far distant stars?
In Einstein's days, it was not clear even what is behind our galaxy. So that was not an issue. There was another issue that had to do with distant, and that is an argument why he had to keep it close and not because the idea was that there is a universe, and if we let it expand, then we would have to remove our boundary conditions further and further away, and that was unacceptable to Einstein. But what you are talking about would have come much later, when the Mach principle was totally abandoned. In 1954, I don't have the quotation here, he wrote a letter to Pirani admitting that he was committed to this idea fix, but he now thinks that we should not mention it anymore.
Thank you very much for a wonderful talk. I was really pleased you mentioned that 1945 article. It's very important to me. I noticed his solution in that article for the problem of the time is very interesting. At one stage in the article he says, well, of course we have made assumptions about isotropy and homogeneity, and presumably in the early times these assumptions will not be justified. And we forget today, we see the universe as extremely isotropic and homogeneous, but they didn't know it. So it's very, can I just add to that though, as Harry Nussbaumer in ETH and Norbert Straumann have pointed out, it's very interesting that he leaves the door open on curvature in that article. He says it could be closed, it could be open, but he certainly does not leave the door open on the cosmological constant. He closes it firmly, and that's why I'm a little bit puzzled. Gamow documented several times that Einstein said this to him, So I see no I mean, I've read all the accounts. I see no reason to doubt him at his word. I mean, just because he liked to joke, I would not doubt Gamow until I see evidence that Einstein didn't say that. I think it's perfectly possible he said it to Gamow. Why not?
Look, there is a recent book by Livio. I forgot the other. Mario Livio, about his great blunders. And in that book, there's a very long discussion exactly of that thing, with a lot of attempts. It is guesswork, there is no evidence, but his final conclusion is that Gamow invented it. And he then, to support it, shows all kinds of instances where Gamow a little exaggerated what was told to him, what he read, and this. But I cannot judge that.
Okay. Was one question? One more.
You have mentioned in your talk the various attempts to unify gravity and electromagnetism. And it's very well known that Einstein rejected this attempt very strongly. Could you say a few words about this?
About what?
About the relationship of Einstein with Weyl with respect to this attempt by Weyl of unify gravitation and electromagnetism.
Okay, with Weyl. First of all, let me just say one thing because I forgot, since you mentioned Weyl, I should have said it. He is the greatest respect for Weyl. In fact, several times he recommended to his readers in introductions to the booklets to read Weyl, but in the meaning of relativity, more than once, even more than twice, he refers to Weyl and praises him for introducing Levi-Civita's methods into physics, which was in Weyl's book. Now, at first, the reason, you see, when with Weyl's model, where he does this affine connection, where you change the size or the length of a vector, and you do a closed circuit, then it turns out that measurements of clocks and rods will depend on the path. And that Einstein could not accept. He overlooked it at the beginning, and he told Weyl that he will help to submit that to the Prussian Academy. When he realized that, he wrote to colleagues that this is nonsense. David.
Just to rise to the defense of Hermann Weyl, that error or mistake is an example similar to that of Einstein of making going on off in the wrong direction, but introducing. Weyl shortly after understood that if he changes the local scale invariance to a local phase invariance, he acquires a much deeper understanding of Maxwell's theory and introduces for the first time path-dependent gauge theories. The modern view of gauge theories stems from that failed, wrong attempt of Weyl to introduce a local scale invariance. So in fact, in the end, it worked out great with a slight rotation to imaginary phase to a phase vector instead of a length.
Yeah, certainly, but you know, this is people's nature. You may be forgiving to your errors, but be harsh on other people's errors. And I mean, it was not, I mean, we refer to all these things as errors. They were the most productive side ways of thought. I mean, going aside, then later realizing and coming back is always with some greater additional truth or understanding. So, yes.
I also, didn't Einstein get disillusioned with Mach's principle because of his calculation of the metric inside a closed shell? Closed shell. Wasn't
Of the calculation of the closed shell,
yes.
and what is in.
Yes.
Okay, but that was again, that was another mistake. That is what he did in this with Bessel, where he tried when the rotating closed shell, and that is what led him to this conclusion that you can have rotation at rest, and that gave him additional confidence in proof theory. But there was a mistake in that calculation.
Yes.
Yeah.
But when did he realize that that was a mistake?
When did he realize that? I think summer 1950. Although Bessel wrote to him about it earlier than that, and for some reason he ignored it. Yes, Bessel wrote to him immediately, but
I think there are more questions now, but I think we're already rather late, so I invite everyone to cluster little grouplets and maybe discuss over a glass of wine. So thank you very much for really beautiful and